All right, guys, so this problem asks you to calculate the number of moles of lead in a particular sample of lead. So how many moles of lead atoms are in a sample of lead that has a mass of 54.67 grams? And so what I want to do is I'm going to use use this pretty standard problem solving method where I organize myself in these three different steps. The first step is to ask myself, what is the problem given me? And the problem is given me 54.67 grams of lead. The next thing I do is examine the words in the word problem, and I ask myself, what is the problem asking me for? Now, I'm asking, what is the problem asking me for in terms of units? It's asking me for an answer in the units of moles of lead. And so organizing myself this way, what is the information that I'm given, especially in terms of the units, grams of lead, and what am I asked for in terms of units? In this case, it's moles of lead. So this allows me to do the third step, and the third step is conceptual planning. Now, usually there's two things that I do at this point. I write down a basic plan, and now a basic plan is just the overall goal of the problem. The goal of the problem is to convert the units in the first step, step one, to the units in the second step, step two. And so I'm just saying the basic plan is to do what the problem asks, and the problem asks me to convert grams of lead to moles of lead. And so I write that down. Grams of lead converts to moles of lead. Now, the challenge becomes, is there a direct relationship between grams of lead and moles of lead? Or if not, then I have to develop a series of conversions that allows me to accomplish the basic goal. Now, in this case, it's a pretty straightforward problem. So there is a direct conversion between grams of lead and moles of lead. I get that from the periodic table of elements. The periodic table of elements lets me establish this equality, that for every 1 mole of lead, there are 207.2 grams of lead. So once I have this equality established, I can write two per expressions or two conversion factors. A per expression is the same thing as a conversion factor. One of the conversion factors or per expressions I can write is 1 mole of lead over 207.2 grams of lead. The other one I can write is just the inverse of that, 207.2 grams of lead per 1 mole of lead. And so now that I have these per expressions derived from the equality that I got from the periodic table of elements, I can start to solve the problem. I can put it all together. So starting with 1, I write that down, the 54.67 grams of lead times the one step. So this arrow, grams of lead to moles of lead, since there's a direct path, I know that I only need one conversion factor, one per expression. And in order to figure out which per expression I use, I examine the units. And so this is the analysis, the unit analysis part. So I've got grams of lead in the numerator. So in the per expression, in the conversion factor, I'll need grams of lead in the denominator. Now, my goal in this step is to convert to moles of lead. So I know that moles of lead will have to be in the numerator of the conversion factor. So that allows me to pick the conversion factor that I need. And so we see the one at the top there circled. I have 1 mole of lead per 207.2 grams of lead. So now I can put in the numbers. And if I get out my calculator, I'll see that it's 0.2639 rounded to the correct number of significant figures, 0.2639 moles of lead. That's my final answer. Okay, thanks guys.